One thing you're going to need to be aware of when programming C that is less emphasized in other more modern languages is the use of pointers. It's not to say that other languages don't have pointers, it's just that they tend to do a little bit more of the thinking work for you around pointers. They limit them in some way and basically help you not make mistakes. But that also prevents you from doing certain low-level things quite as easily. C++ coming out of C's original language really is keeps some of those ties to lower level languages. So there's less of a separation between values and location. It's up to you to conceptually remember the differences between them. So the idea behind a pointer is pretty simple. There is a place called the White House, 1600 Pennsylvania Avenue in the United States. If you're from the United States, you probably know that address fairly well. If you're coming from another country, you might not have heard it as much, but the place where the President of the United States lives is 1600 Pennsylvania Avenue. Um, that is a physical plot of land in Washington, D.C., and there's a physical building on that physical plot of land. So you can think of it as an object. It lives at some place, at some location, and there's some data that's been stored up inside of it. The address in your address book, using analogy, is like a pointer. It tells you that number, 1600 Pennsylvania Avenue, Washington, D.C., and it tells you where to go to access information about that. So if I give you a copy of my address book, I'm not actually giving you the property. I'm not giving you my house. I'm not giving you my bank. I'm not giving you the president's house. I'm giving you a copy of the references to those places. So it doesn't entitle ownership; it just entitles access, if you will. But because I have the address 1600 Pennsylvania Avenue, it doesn't actually give me any information about what's going on inside of the White House. I don't know who's talking to whom or what the rooms look like. I can't walk in there anytime I want to. There's nothing inferred by that. So it's really important to understand the difference between pointers and values and references and values when you get into the code. So when I go off and create an object, I create the values that are in there someplace in memory. Now I put this at 0, it could end up anywhere in memory, but at the 0th location I have the 1600, and then 2 bytes later I have Pennsylvania Avenue, which is another let's see, it's not 12, it's F, so it's 17 bytes. And then there's another number 8, E is 12, another 8 or 9 bytes here, and then DC and so on. So this is what this object might look like in memory. And so this object lives at some location. So the property of the pointer to that, it points to the value in memory 0000, wherever that object would be created out there in memory. This is a little bit of some systems programming concepts that's leaking in here, but that might be something you'll come to at some point in your programming career. So when I create a variable that is a pointer to something. So like let's say this value called White House lives at the address 0025. Its initial value actually starts at 0, and in this case when I initialize it to point to that White House, it also has that value of 0 inside of there. And if that value was something different, 074F, that's what would get put inside of here, is the location of where this thing's at. So the actual data location is kind of like at the building, and then this is kind of like the reference in my address book to tell me where to go find that. Now, what that looks like in C++ is very subtle. If I go through and create something like this, I call the variable White House fixed. This actually creates a variable and an object all at once. And so this points to the White House fixed points to this object I just created. And if I want to create a pointer to the object I created, then I do it slightly differently. So I say I put this little star out here, and a pointer to the White House then says I'm pointing to this new address that is the same data. So this would actually create 2 instances in memory. There'd be 2 copies of this in memory at different locations, and this would point to this and only this. This would point to this to start with, but could point to something else later on. And so I can actually create a address, a pointer to that, which is the White House. This is what I'm creating down here. This White House variable can point to any address out there. It can point to the White House. It could point to the bank. It can point to the trash heap down the street, as long as it's an address. So I can go through and say this White House pointer, the White House is equal to that White House pointer, no trouble. Just right away I can point to that because they're both addresses. It just copies over memory values just like you would copying over 4 or 5. But if I want to point to a fixed object, I have to use this little special ampersand character that tells me that I want the address of the thing, not the thing itself. So I'm not pointing to this value of the whole object. I want the address where this object lives out there. So this changes stuff around quite a bit. So this first address does not change to point to any other object, where the second one could change to point to a different object. So the first one is really nice because it means that anytime I use the variable White House fixed, it's referring to that same plot of land. That's where the White House is a good example here. We don't typically change the location of the White House, in this country. I noticed I didn't call the variable President's headquarters. That could change in times of conflict, or maybe they're doing a remodel or something. The president's headquarters could change to someplace else. That's why the idea of Air Force One, the airplane that the president flies on. Well, there's many airplanes. There's actually 3 747s, any one of which could be Air Force One. Or if the president gets on a commuter jet, that would technically be Air Force One at that point. So that second one, the idea of the pointer to a thing allows you to change the physical address as needed. So this brings up some really interesting points in code. If I look at these 2 lines of code, what gets printed on either one of these lines of code? So the first one is pointing to the variable White House. Remember, we declared that as a pointer. And the second one is doing star White House. And so they look close, but there's clearly a difference. The star means something. So the first one out here actually is a pointer, and so it actually print the address of the thing that's out there. And so that has to be initialized to something. If you don't know what to initialize to, you initialize it to null, capital N-U-L-L, which has a value of 0. The 0th address is normally something reserved for the operating system, and so you wouldn't have access to that. Anyway, for the most part, you shouldn't be writing to it. So, the C language says, hey, if it's 0, I'm not going to write to it. It's a bad thing. Go away. So the White House with the star in front of it would print the value of the object. It's called the dereferencing operator, and that's assuming that it has that proper override. We talked about that in this earlier video. But if I've overridden the arrow operator right there, then it will print out that value of the object appropriately. So that's an important difference right here. So if I create something with a star and print it out without the star, it's going to print out the addressed value. Think of it this way. If I will go to print a picture from my hard drive, I don't want to have it show up the folder where that printer lives when I go and print it out. I want to actually print out the picture, unless I want to know what folder it lives. So I have to choose, am I printing out the folder location, or am I actually printing out the picture? That's the choice here, and it's up to you. Some languages don't make this differentiation. You can never really print out the address exactly, or you have to do special syntax to do that. And C, what gets printed out or what gets used in your code is what the type of the variable is, which makes some sense. It just means you have to do a little bit more management. The other operator that's important to pay attention to here is the ampersand operator. We saw that a little bit before, but let's dive into it again. So I could say, for instance, in this case, I have the street number is an integer, 1600. And then I create the fixed address of the White House, and you see I'm passing in the street number to that one. And then I have the address White House, and the address White House is pointing to the ampersand of the White House. It's the address of the White House. I couldn't actually put White House fixed inside of here because that's the whole object. I can't store the whole object in a pointer to the object. So I have to put the ampersand outside of there to dereference it. But let's look at these print lines here, these outs that will give us the difference. So I can take an out of the street number versus the out of the address of the street number. And when I do that, it's 1600, the value of the integer that gets assigned up here, versus this big long hexadecimal string. So 001C, C and F are hexadecimal numbers at this point. F is 15, C is 12. Yes, it's 12. So that's the hexadecimal number somewhere in variable, in memory. And then, like we just saw there, the White House versus White House fixed, the White House itself, the fixed, prints out the whole address that we put into it, where the ampersand in front of it, the address of, again, puts out one of these address operators. So if you're ever running your code and you have some little funny address that gets printed out, that's the reason why. So this is the start of our operators. And playing with them. The biggest lesson here is just you need to be really attentive to, do I want to point to a thing or do I want to store the thing? And that's going to have some ramifications, as we're going to see in the next video, on how we pass parameters and manage objects through the rest of our code.